going to be talking about, as you might already know, web-based virtual reality made terribly easy. Well, there is a way that I call this session terribly easy. You'll probably know by the end of this session. So before we move on, just a heads up. How many of you are web developers? Okay, great. And how many of you have prior experience with virtual reality development? Okay, great. So it's going to be an interesting session for both of them because you'll get to know why. A little about me. I'm Srushtika Neelakantam and I've been volunteering at Mozilla since the year 2013, where I'm a representative, a tech speaker, as well as a campus advisory committee member. And most recently, I've co-authored this book called Learning Web-Based Virtual Reality. It's available on Amazon. You can go check it out after this session because it contains advanced, concepts of what I'm going to be covering in this session. So let's get into virtual reality. What basically is virtual reality? If you've attended the previous session that was happening in the main hall, you most probably already know about it. So virtual reality is being able to build an immersive and interactive another reality, another world around you. So you can transport yourself into a completely different new world using virtual reality. So how can you achieve that? You can see the video playing in the background. You can do all cool things, but how can you achieve that? You have something called a VR headset that you put on, like the one which is right here. You can probably try it after the session if you want. So there are different kinds of headsets. Obviously, they're not all the same. So they differ in complexity. If we go from here, there's the Google Cardboard, and at the end there is HTC Vive. Now what's different is Google Cardboard is obviously cheap. It's around $5, that's it. Whereas your HTC Vive is around, $800. Yeah. So it's really, they have a lot of different features. That's the way. That is the reason they differ in their price so much. With Google Cardboard, you get a very basic experience. It's not that great, even if you have a great phone. The lens are not up to the mark, and you get a very basic experience which you can probably try for your first Hello World experience. But you will feel the need to get a better VR headset as you move on with the development in VR. So moving on, we also have the intermediate stage VR headsets with which you get a Bluetooth enabled remote, using which you can add interactivity to your VR applications. So if you want to say click a particular thing, you can use those remotes, which is not obviously possible using the Google Cardboard. And then obviously HTC Vive, you have these controllers with motion sensors as well as positional trackers. Now what are positional trackers? If I put this headset on and move around, I might just bump into the wall because what I'm looking at is not the real world, and it really doesn't know if there's a wall ahead or if there's a road. I might see a playground, but in reality it's just a room and we have limited space. So with positional trackers, it tracks the objects around you as well and lets you know, it changes your virtual environment according to those objects, so you don't actually get yourself hurt. That's the additional features that are available with HTC Vive. And then these headsets are also categorized in another category, that is tethered versus untethered. So the tethered ones are something which have a wire attached to them, and that wire is connected to your PC, and the PC is responsible for generating your VR content. So whatever you see on your screen is generated from your PC, and as I was told in the previous session, you need to have a powerful PC obviously because there are a lot of 3D graphics playing in your system, right? And then we have the untethered headsets, where you don't need to have a wire connection. It's just wireless, but then you can have a mobile phone placed inside this, like you can see here. If you open it, you just place a mobile inside, and that is what generates your 3D content. Otherwise, you can also have something like HoloLens, which is a mini computer in itself. You don't have to place your mobile as well, and no wire also, but still it generates your VR content and you're able to experience VR. That's about the headset. Now, what is the problem we have with the current VR ecosystem? There are a lot of gatekeepers, right? For instance, how many of you are Android developers or iOS developers, mobile developers? Yeah. So when you create any applications, obviously you can create VR applications as well on those platforms. But when you do, you have to get permission from the gatekeepers of the iOS store, App Store or the Google Play Store in order to let your app show on their store, right? So they have certain criteria of whether or not to let your app show on their store, or even it takes time. So even just imagine that there are no gatekeepers. You just want to put your app on the app store and it just shows up. But I still have to download it and install it, right? And VR as such is very heavy. So it takes hundreds of megabytes of my phone memory, and someone like me who likes to click everything I have around me, I need space for pictures, right? So I don't want to waste a lot of those MBs for just one simple VR experience. So there are installs, so that's the problem. And the current ecosystem is closed. It's almost like a black box. You do not know how the code is written, and you can't play around with it. If you have a simple VR application that you like and you want to build something similar to it, it's really difficult because it's all closed source. So what can we do about it? Introducing WebVR. So you probably have heard of this term WebVR. It's just a virtual reality platform with the advantages of the web. Right now, with WebVR, you don't have applications anymore which you have to download. It's just your browser, and you just hit a URL and you're able to experience VR. So no installs, no more downloads, and it is open source. So you can, for every application, you have the code available, play around with it, submit your own patches, and you know the advantages of open source. And then it is connected. Now what happens in a web? You have your website, right? How do you navigate from one web page to the other? You use something called hyperlinks. So that way, web is connected. So you can navigate from each web page to every other web page using these hyperlinks. And exactly the same is possible using WebVR for virtual reality scenes. Now, like we have web pages for websites, we have something called scenes in VR. So if I build this particular room in a VR, that is one scene. So I'm able, even if I turn around, all I can see is just this one room. I can't see what's happening outside. If I want to go outside, I'll probably place some trigger that if I open the door, I'm able to see outside, and that's a different scene. So it's like navigating from one web page to another. So it's connected that way. And then obviously it is instant. You don't have to wait for your app store owners or anyone to let your app show in their app stores, or you don't have to wait and download and install it anymore. Just hit the URL. So I'm really free this weekend, and I happen to build one, say, virtual reality website, and I want my friend to try it out. What I do, I just post it on my website or probably on GitHub pages, and I just share the URL with my friend, and bam, he can experience virtual reality right there. So it's completely insane. Now, if we go with a little more formal definition, WebVR are the browser APIs that enable WebGL, rendering to headsets, and access to VR sensors. Now what this means is you have your sensors either in your VR device itself or in the mobile phone which you plug into the headset, right? So WebVR allows your WebGL to access those sensors and then use them to build your virtual experience. So it does all that by itself. So you don't have to worry about the boilerplate code anymore. You don't have to worry about the JavaScript written behind it. All you do is just the front end work of it. So it's just easy like that. But sorry. Yeah. Now because WebVR is very new technology, the support for it right now is really less. It was initially proposed to be to allow working only on Firefox browser, but then eventually they extended the support to all these browsers, and for those browsers which still do not support WebVR, there is something called mobile polyfill. I'm sure most of you know what a polyfill is, but for those of you who don't, it is just a piece of software that allows your browser to mimic a particular functionality that it by itself it does not support. So you have mobile polyfill for those browsers, and for the other browsers, it's anyways they support. So it works on all the mobile devices for now. And if you don't have a mobile device or a VR headset to check, it obviously works in a browser in your laptop. Only thing is you don't get position trackers, so you use your mouse to move around and just check. It can be used only for testing your scene, so it's not an experience in itself, right? Now I've been talking about WebVR, and what's the difference between the normal VR stuff and WebVR? It's just that we don't have applications or downloads anymore, and we just build it on the web. Is that all the difference? It's still hard, right? Why did I even have to name my talk terribly easy? It's still hard. You have to, like, for the simplest of even for the simplest of the Hello World application in WebVR, you have to do so many things. You have to import the WebVR polyfill, set up the camera, set up the lights, and do so many things even for your most basic Hello World application. So why is it even easy? Now let me introduce the A-Frame. Now the A-Frame is a web framework built on top of WebVR. It's a declarative framework that allows you to get unlimited access to all these JavaScript and everything that goes behind the WebVR, and then it allows you to write your VR using just HTML. So I'm sure most of us have learned HTML in our high school, and even if we haven't, if our syllabus was different, it just takes maximum, say 24 hours to learn HTML, that's it. And if you're able to create something as cool as VR using HTML, how cool is that? Is that easy now? Yeah, terribly easy? Great. So let me show you actually how the code looks for a basic Hello World application using A-Frame. So there is a JavaScript source file which you need to include in your HTML code. So obviously HTML works in terms of tags. We have the starting and the ending tags, and you just include the particular JavaScript source file, and then you have something called A-Scene. There is a stack called A-Scene, and you write all your objects, all your components that you want to include in your virtual reality website inside these two particular tags, right? So now let's see what we want to build for our Hello World application. So I would like a sphere, a box, a plane, and just some gray background. So there's something called sky, the A sky. In virtual reality, what a sky means is, except for the plane on which you're standing, all the other surrounding, the four surroundings plus the roof make up the sky. So for instance, I want to build a scene where I'm standing on top of the world, like on top of the earth. I just want to feel that, because obviously it's virtual, I can make anything. So I just take a 360-degree image of the sky, a starry night sky, and I just use it inside my A sky tag, and it just puts that sky for my virtual reality scene. But for the Hello World application, let's just take one plain color as a background. Let's not take image. So this is how it looks. That's it. 5 lines of code. You have the A box, the tag A box, and then just like you do it for every other HTML tag, you write your attributes, the color, position, and rotation. There are other attributes as well, but for now we just look at these 3 attributes. And the A cylinder, okay, there was a cylinder with some particular color, and there's a sphere, a plane, and there's a sky. As I said, we are using color for the sky. We can also use SRC and include an image, a 360-degree image for the sky right there. So let's see how it looks in the browser. So this is how it looks. But obviously, it looks really pretty basic. So we might have that misconception. So we've written very easy code, and it just builds basic VR websites. It doesn't probably build amazing games or amazing experiences that are usually seen in your normal VR applications. If that's not the case, this was the just the Hello World application, and that's the reason it looks really basic. But this is the same kind of simplistic code that you have to write even for the most immersive of VR experiences that you build using A-Frame VR. I'll walk you through the applications and examples by the end of this talk. Now for the web developers who use all kinds of different frameworks, JavaScript frameworks, A-Frame can be integrated with all of these. It works with everything. So you name D3, Angular, jQuery, Redux, it works with everything. So it has support, and you can just directly integrate your available application using A-Frame. You can just extend virtual reality to it. Now, if you or any of you over here have any experience working with 3D models using Unity or anything? No? Okay, so basically how all this 3D world works is using something called entity component model. Now, in the previous VR scene that we saw, we have this sphere, we had this cylinder, and all these components, all these objects. So we call these objects as entities. All these are entities in our VR scene. And then we added color to them, we added, say, rotation to them, position to them, and scale to them. So I want my cylinder to be so small, but my room is so big. Now there is a difference between the dimension and the scale, right? The scale is how relatively big your object is, and the dimension is, by itself, what is the dimension of the particular object. So I have these entities, and I add all these components like geometry, the material, the light, and rotation, position, and all these things to these entities. So that's how the whole of A-Frame works. It's based on the entity component system, right? Now A-Frame ships with these basic components for now. So there are just a couple of them like the position, rotation, and hand controls for HTC Vive and things like that. But A-Frame has such a huge fan following that a lot of contributors have made their own components. Obviously, A-Frame is extensible, and you can pitch right in and contribute to the project. So a lot of contributors have made their own components and gave it back to the project. And now A-Frame supports so many other components as well. So for every entity, you can use all of these, any of these components to add functionality to your objects in your VR scene. Now there's something called A-Registry, which is a curated collection of all these components. So in case you want to you like this A-Frame and you play around with it, maximum it takes 1 day to understand how things work, and you can start building your own components. And if you want others to be able to use your components as well, you can submit your work to something called A-Registry, and people from the Mozilla VR team will curate your component, and if they think that it is good enough and it will be helpful for people, they will make your project available on this A-Frame registry. So others can use it from there as well. It's again just by including a JavaScript source file in your HTML code. Yeah, so very recently someone just made these leaf hands. So using HTC Vive, you have these two controllers, and you can actually play around with your hands and do like pick up objects and drop objects. Not the real ones, of course. We are talking about virtual reality. So we have your virtual. Say I have a virtual ball, and I'm in a bowling arena, and I can pick up the ball and throw it towards the stand and things like that. Do things like that. Now we have this very good tool which comes with A-Frame called the Inspector. It's a visual tool available in your browsers where you play your A-Frame. You just have to play your A-Frame application and then go to Control-Alt-I. And what happens next is you get this kind of a visual representation of all the objects which you've added. So for instance, if you have your position and rotation set to some values initially, but you feel, okay, the particular dragon should have been right on the Pokemon ball. But you can't waste your time playing around with doing trial and error with all the positional attributes, right? So what you can do using Inspector is directly drag and drop the dragon onto the ball, and it will set the coordinates itself. How cool is that? So that is something available already, and you can just try it on all of your A-Frame scenes when you play it in your browser. Now let's get to the interesting part. What do you think are the applications of VR? Is it just for play? Is it just for fun? Any idea of what VR could be used in other than games and having fun or entertainment? Any idea?
Store. Use a store.
Okay.
Surgery.
Yeah, great. So for instance, you can just sit at home. What he's saying is you can just sit at home and you have a virtual store, pick up items and put them in your cart and then do the billing. Just like you buy something on Amazon.com. Except for now, you see a real store, a virtual store, just like how you see it in real life. Yeah? So we have other applications as well. And A-Frame very recently introduced something called the A-Painter, using which you can actually draw in the air. So you have these controllers with HTC Vive, and you can pick up your color and you can paint in the sky. You can walk around your painting and you can draw something on the rear end, something else on the front end, and it's a 3D painting which you draw and completely just like that. You pick the colors and you just paint. And in order to write code for it, it's again HTML. So again, the easiest part for a web developer, right? Now we have also, all these, are contributed by people who work with A-Frame, not just the people of the Mozilla VR team, also the contributors from the community, they've contributed this. So for instance, you're working in your office and you have this work of data visualization, you have to show some statistics. What you do? How cool it would be if you ask your manager to wear a VR headset and just pick up one particular tab which shows, say, I don't know what it says, yearly salary something. I just pick that card up and put it here, and then it builds up a graph based on the data inside it, just like that, in the air. So I just put on my headset and I experience all these things. I don't have to, I can even look at the particular graph in different directions, different dimensions. So if the X, it's not just limited anymore to X and Y coordinates, you can also go through the depth, which might correlate with a different value in your data. So that's how it works. And then A-Blast is also introduced very recently by the Mozilla VR team. So A-Blast is basically used for gaming because every other VR framework's main aim is to go for gaming. They actually entered into gaming a little later because that's really common right now. But they did enter. So they're just blasting some innocent animals out there, but it's just to show you that this is available and you can build games as well using A-Frame, which is HTML. Now obviously for medical education, any people who are pursuing medicine, I don't think because it's a technical conference. Yeah, so if, say my cousin is doing medicine from a college. Now he's in his first year and he's no idea of how things work, and he's very bad with textbooks, he can't read things. It'll be, how nice would it be to visualize things? I can tell you, like, I can just pick up the heart, I can randomly place it at a point, but I know that would be wrong if you do it to a real person. So how about getting some practice using VR first, right? So this is again built using A-Frame, and someone from the community has contributed it back as an example. And you can do a lot of other cooler things as well than just what's seen here, right? Now, what about AR? So we have been talking about VR. Does A-Frame also support AR? If you do not know what AR is, it's the virtual reality in the real world. So for instance, I have this room, the room stays as it is, and if I see through my phone's camera, I can see some virtual objects placed in this very same room. So it's the real world plus some virtual objects inside that. So for AR, A-Frame is really, in its early stage with AR. They're not really working a lot towards it, but they have started off. So this is how the first look of AR was using A-Frame. So it's very experimental, so I don't think if you are interested in AR, this is the right time to get started with A-Frame, because it's very, very early stage for A-Frame to get into AR. Now we have something called multi-user experiences. Obviously, no game is complete if you don't have a 2-player version or a 3-player version, right? So how about we try it right now? So I'll show you an application. You can scan this, QR code or just navigate to the particular website, and I will open that on my laptop as well. So it will show you up. I'll just show you. I should have shown the password. So this is an application built by one of the core developers of the Mozilla VR team. His name is Kevin Go. So what it shows is it loads. Yeah. So I'm here. actually open that link are those people. And you can actually try to identify yourself. If you move the phone, that thing moves as well. And if you tap on it, the hands are almost like clapping. So you can try clapping. Okay, so let's do this. People towards my left only tap the phone, and people towards the right don't tap it now. So let's see if that works. Okay, tap. Does it work? Okay, it works. And towards the right, I don't think it's a really good differentiation between right and left, and that's why probably the application is getting confused. So that's how it works. So basically, this is as easy as you have seen here. The multiplayer applications can be, you and your friend wearing two different VR headsets and then playing the same game, right? It would be good enough, don't you think? Yeah. So I have this VR headset with me in case you want to try it out after the talk. And okay, I'll just end this talk with by talking to you about the community. As I said, there are a lot of fans and followers of A-Frame because it's really easy, it's really basic to get started with and actually contribute back to the community. We have more than 5,000 stargazers on GitHub and 300 plus members in Slack. And Slack actually, the Slack channels have people from the Mozilla VR team themselves. So in case you get stuck or you need real assistance, they are there. The people who build this technology are there to help you out. And then obviously hundreds of featured projects. So there is this newsletter called A Week of A-Frame that gets published every week. So if you've done something really amazing, you get featured on that newsletter. Yeah, and there are so many other things. So you can follow A-Frame VR on Twitter in order to stay in touch. And that's about it. Thank you.